Hi, I'm Nancy. I'm currently a sophomore in high school and an admin club officer. Today's just intended to be a quick thing where I go over the ACSL, what it is, and the sort of the problem types for the first contest. I know that a lot of you guys have already taken it, and that some of you have a lot of experience with it already. So this might not offer much new information to you guys, but I hope that some of it is of help to those who haven't or offer some advice anyways. Yeah, let's get started. This is just a quick table of contents. This goes over what we're going to be talking about today. I don't think it should take too long, maybe only about 30 minutes or so. Firstly, what is the ACSL? It's just a yearly computer science competition that aims to test students on various fundamental computer science concepts. It's pretty well known, and I believe it's ranked decently high in sort of standing for college admissions, with over 6,000 students having participated in the 2023-2024 competition sort of year. Next, how it works. The ACSL has one regular season per year. Each season is split into four contests and one invitation-only finals. Each contest covers three individual concepts. For, I believe, the junior division, the third concept will always be what does this program do? But for intermediate and senior divisions, there's an extra concept. Like there's three different concepts each contest instead of two new concepts and one what does this program do? Each contest consists of a short problem section and a programming section. In the past, the short problem section has had 5 short problems to be solved within 30 minutes, and the programming section has had one problem which the student has to write a program to solve, with 5 visible test cases and 5 hidden test cases to sort of test it. Each short problem is worth 1 point, and each hidden test case successfully solved is worth 1 point. This adds up to a total of 10 points for contest and 40 points total. Again, though this is historical, I'm unsure if this year they're making any changes yet, as the website hasn't exactly been very forthcoming with information. So how does it work? Students have to score at least 28 points total to be invited to the finals. The finals occur on one day, synchronously, where every competitor who's been invited to it sort of has to take it at once, instead of the normal contests where you're given a time frame where you can take it individually on your own and like decide when to take it. Like the normal contests, there's a programming section and a short problem section. The programming section is worth 20 points, consists of 2 problems, and should be completed within 3 hours. Um, as some of you guys who might have taken the test have noticed already, the programming problem has been really easy for the first contest. The difficulty will slightly ramp up over the contests, and the programming problems in the finals tend to be a lot more difficult. The short problem section is worth 20 points, consists of 20 problems, and must be completed within an hour. These cover all concepts included during the normal rounds and will not include any new concepts. It's kind of like a big review to test all the knowledge you've sort of gained over the past competition season. No new concepts will be introduced, as said before, but it will sort of reiterate past concepts with slightly amped up difficulty. Again, this probably looks familiar to most of you. There's going to be an invitation that looks sort of like this sent to your email. You'll just click the start test link, make sure you have a steady Wi-Fi connection, stuff like that, and that'll be it. Yeah, that's all for the overview of the ACSL. Next, we'll be getting into Contest 1. We'll be going over the 3 topics covered: computer number systems, recursive functions, and what does this program. Firstly, computer number systems. What are they? A computer number system is just kind of a certain way to represent a number. For example, the number system we use in our normal everyday lives is decimal, also known as base 10, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. This is because it's based on 10 unique digits, 0 through 9. All numbers in decimal are comprised of these 10 digits. When you reach 10, you're piecing together 1 and 0 together. It's consistent reuse of these 10 digits that form up all of our numbers. Other number systems commonly used within computer science are binary, also known as base 2, octal, known as base 8, and hexadecimal, also known as base 16. These sort of follow a similar concept, where while decimal has 10 unique digits, binary has 2, 0 and 1, octal has 8, 0 up to 7, and hexadecimal has 16, where, as you can see on the side, it goes from 0 to F. After going past 9, it uses letters A to F. Numbers are written like this, with the number and then a subscript denoting the base. Numbers written without a subscript are typically decimal. Over here on the side is a chart. This is a screenshot from the ACSL wiki. It's a great resource that I'm sure all of you are aware of. I thought I'd just pop it in here because it shows numbers in different bases. As you can see, decimal goes from 0 to 9 before going looping around. Decimal 0, 1 before it loops around. Octal goes up to 7 before it sort of loops around as well. And hexamal goes up to F before, yeah. As you can see, octal only has 8 digits to 7. So like when we reach 9 in decimal and wrap around to 10, octal does the same when reaching 7. And hex goes up to 16 digits by using letters after 9. As you can see here, when decimal moves to 10, hex sort of goes to its next quote-unquote unique digit, A, and continues to F, where it goes to 10. This is basically in addition and subtraction in decimal sort of also holds the same concept as in other computer number systems. I find that I'm more confident in converting everything to one base, for example, decimal, when I'm met with problems in the ACSL that ask me to subtract numbers of different bases. But if you get familiar with addition and subtraction in different bases, you can save a lot of time on just doing that instead, as it follows the same general concept. First, we'll go over really quickly conversion to decimal from any base. Consider just a normal number in decimal. This number is essentially 263 is also basically 2 times 10 to the power of 2 plus 6 times 10 to the power of 1 plus 3 times 10 to the power of 0. You can sort of check this in your calculator if you want. Basically, each digit times 10 to the power of the place starting at 0 from the left rightmost end added together. To convert a number in a different base to decimal, you're just basically doing the exact same thing, but instead replacing 10 with the base. This would mean that 10010 to the base 2 would be 1 times 2 to the power of 4, that's its place. 0 over here would be at place of 0, and 1, this one, would be placed 4. That's why, 1 times 2 to the power of 4, plus 0 times 2 to the power of 3, plus 0 times 2 to the power of 2, plus 1 times 2 to the power of 1, plus 0 times 2 to the power of 0, and then add that all together to get 18. Remember, the place it starts at is 0, so this is 0, 1, 2, 3, 4. The formula is digit times base squared by place to the power of place, plus digit times base to the power of place, and then this repeated for each digit. Next, let's do some practice. If you guys have already taken the test, again, I'm sure you're already really familiar with this or done any of the short problems, but I thought that it couldn't really hurt. So if you guys want to, you guys could grab out a piece of paper and quickly write down these two. I'll give us 5 minutes. I have not really received a response, but I think that it's been long enough and that most of you guys are likely done or haven't started on doing it. We'll just move on to the answers real quick. So those who have done it, you can sort of check your answers as well as the process you did it with. Next, we'll move on to conversion from decimal. Let's start with an example. 7,381 base 10 to base 8. What you want to do is to first find the largest power of the base you're converting to that's smaller than the original number. In this case, this would be 8 to the power of 4, 4096, as 8 to the power of 5 is 32768, which is bigger than 7381. Next, you want to divide the decimal number by that number, and you want to keep the remainder. So don't go fully into long division and divide until you get a decimal point. Just stop once you've gotten past integer and write down the remainder. Next, we take the remainder and repeat the previous process of finding the largest power that fits. Now 8 to the power of 4 is too large, so we use 8 to the power of 3, which is 512. We get 6 with the remainder of 213. We repeat this. As you can see, this is sort of the process we take. Finally, we just take the results of each calculation without the remainders, so these numbers, and then compile them into one final number. This is an addition, just putting each digit after the other. The final answer is this octal. Next, let's move on to conversion between binary, octal, and hex. This is a lot easier than the last ones, though you will need the table for it or have some stuff memorized. To convert octal and hex to binary, you want to convert each individual digit to their corresponding binary bits and then just group that into one string. To convert from binary, you split the binary string into either groups of 3 for octal or 4 for hex, starting from the right, then convert each group into their corresponding digit. If, for example, as you can see with this string of binary, everything splits perfectly into groups of 4. But in the case that it doesn't, just keep it as that and it converts fine either way. You convert each group into their corresponding digit in hex or octal or whatever, and pile that together, and that's your answer. For this, you will want to, I found that it's helpful to write down the chart here at the start of the test, as it makes that a lot easier. Next, recursive functions. Hooray! Recursive functions in mathematics are essentially functions that call upon themselves. These have a lot of various forms in various fields. They come in word problems, philosophical concepts, etc. In ACSL, the two most common problem types look something like either this. You'll probably get a guaranteed problem that looks something guaranteed like this, or a word problem something like this. We'll go over how to solve the first type of problem first. All problem types just need to be worked through methodologically. Make sure to check what you're writing down on paper. First, to solve these, you want to calculate the stuff inside the function parentheses. A number will be provided to you. In this example problem, screenshots taken from the ACSL wiki, the number is 13. You plug that number into the rule it matches. In this case, 13 would be going to the top rule because 13 is larger than 5. You plug it in, put it through this, and then write the number down in this form. Next, you take that number and then continuously plug it through these rules until reaching the result at which there's no more function inside it, in this case just x. Then you start working back up. After you've written down everything, you know that h2 is 2, so you plug this back into the previous function, and you repeat until you're all the way back up at the top with one number. This will be your answer. Pretty simple. These can get kind of long-winded and use up a lot of space. So again, I know I've already said this like twice, but please make sure to write down everything you're doing. Don't try to calculate it inside your head, and try make your work as neat as possible. It When working with long and complicated problems, not necessarily complex or difficult, just ones that have a lot of steps, it's kind of crucial considering you'll be working back up. As there can be a lot of variation with the other problem types, there isn't really a one and done sort of formula for those, unlike this type of problem. The only advice I can give is to just, again, write down everything step by step on paper. Consider things logically, make sure that sort of check over your thought process with each step. If there's a problem that seems excessively complicated or calculation heavy, there's probably some sort of mathematical pattern that's intended for you to figure out, instead of that you should try and find instead of just brute forcing the whole thing. Good luck. Next, we'll move on to what does this program do? Uh, these two sections are going by a lot quicker than the first, and I guess that's just because these sort of rely a lot more on sort of gain knowledge instead of formulas. This will probably be the section in which I can offer the least insight. All you need is just a very basic understanding of essentially any high level programming language to do these. That'll be Python, C, Java, etc. Um, and it'll be basically all you need. This includes understanding of operators like plus, minus, division, modulus, if else, and else statements, loop statements, arrays, and string manipulation. Um, the problems will be in pseudocode, so again, you don't need knowledge with a specific programming language, just as long as you know one and how it works, you're basically good for these. Um, the pseudocode that ACSL uses has some specific terms that you can check out if you want. However, I don't think it's very necessary. They have a big table on the wiki, so you could take a look at that if you'd like, just to make sure that no confusion occurs. I found that the main challenge with doing these is sort of keeping track of everything. Again, as before, these aren't really difficult. It's more of the amount of steps that they give that makes mistakes so possible. There are often problems with a lot of variables going through a lot of changes, which are all dependent on each other, where one issue on the way leads to the incorrect answer. Again, like I've said a lot of times before, just try and write down everything in an organized and understandable format on paper. Go through every step, make sure that what you're doing is sort of, yeah. When I do the problem, I like to sort of make a table where I list down each variable and mark down the changes they go through within each step, just to make sure that everything's fine. Next, we'll move on to a sort of general tips section. Regarding number systems, I think I've mentioned this before, but try and memorize the table of binary, octal, decimal, and hex numbers up to 16 shown earlier, and write it down at the start of the test. This will help you massively with decimal, octal, and hex conversions. Like, it, yeah, it also prevents mistakes where during the test you might not be thinking at full capacity as you would have before. So it's helpful to just write down equations and other things at the start. In general, okay, yeah, I'm gonna skip the first point. I've said that far too many times. But write everything down, keep track of your work. Next is sort of a general test taking tip, keep track of time. Remember, at least in the past, you have had 30 minutes, you will have 30 minutes over 5 problems. You need to make sure to allocate time properly. If you get stuck on one problem, move to a different one and go return to it later. Finally, check your answers. If you work through things quick, and you have extra time, it's always good. As redundant as it can seem, with the first contest with 2 categories being a lot of steps where you can make a lot of mistakes, even just looking through once or twice can help you sort of save yourself a point. And that's pretty much it. Yeah. So that was pretty short, almost 30 minutes. Thank you guys for sitting through this. I know that, again, most of you have already taken the test, a lot of you have previous knowledge, so this probably didn't offer much new things that you guys didn't already know about. But I really hope that some of it, at least some of it, was of help to you or the people who haven't taken the test yet. If you guys want to contact me, that's my email right there. If you guys have any questions, you can ask it now. I think, yeah, that's pretty much it. If you don't have anything, you can feel free to leave. Thanks for coming.